All right, here we go. Video number 2. This one will be a little bit shorter than video 1, so don't get too worried. We were finishing off the last video, in case you took a break, working our way from the Earth's surface up through Earth's atmosphere. And so we had just finished off the tropopause, again, the layer of the atmosphere where sensible weather occurs, the stuff that we are accustomed to dealing with as humans on planet Earth. And so as we work our way up, we next find ourselves in the stratosphere. And one of the big things that I noted early on was the fact that you can see that red trace. And so once you leave the troposphere and enter the stratosphere, you notice that your red line starts curving or slanting back to the right. This is showing that the temperature is increasing through the stratosphere. In fact, the way that we identify the tropopause, or the layer between the troposphere and the stratosphere, is when we see our temperatures stop cooling regularly with height and begin to warm. And so the stratosphere is naturally an inversion, remembering that term from the previous video as well. The stratosphere, as you can see here, is going to be a thicker layer of the atmosphere than the troposphere. The one thing that's actually mentioned, and in that blue oval we see on the screen, is going to be that this is where the maximum in ozone lays, about 25 kilometers above Earth's surface. As mentioned previously, ozone is an interesting gas in the sense that it is going to be critical up here in the stratosphere to absorb the ultraviolet energy that's coming towards Earth from the sun. UV energy is very powerful and can cause skin cancer, and is one of those things that we need to avoid as humans. It's why you have to wear sunscreen when you go to the beach. The idea that you're going to look to have that UV protection in both the A and the B portion of the spectrum. So again, the ozone up here basically absorbs the vast majority of incoming ultraviolet energy, and as it absorbs that energy, it warms the stratosphere. And so that's going to be the main reason that the temperature here increases with height. Working our way up one more step, we find ourselves in the mesosphere. We won't spend a whole lot of the time in this course in the mesosphere and the thermosphere. We're getting pretty far up there. We're still in the homosphere, but you're getting to where it's now cooling again with height. You can see the temperatures in the mesosphere actually are quite cold. And because we talked about atmospheric pressure being basically the mass of the air above you, there's not a whole lot of mass left. And so the pressure is very, very low. You have a very low air density. It would be completely unable, you would be completely unable to breathe up in the mesosphere. And so you can see, at least in the inset photo here, the meteors, the idea that in the mesosphere, the meteors that are coming towards Earth typically, for lack of a better term, burn up as they come into the mesosphere. And so there's not a whole lot that we're going to spend time on up here, but it is still notable. And finally, as we get towards outer space, we reach the thermosphere. Thermosphere, you can notice that red trace slants sharply off to the right, and you may be thinking to yourself, whoa, the temperatures are really hot in the thermosphere. In fact, you're going off the chart. But the issue here is that you have so little air that even though the motion of the air molecules is extremely fast, thus the high temperature, we'll get there, you would have so little air moving around that it would feel still extremely cold. So you would not be warm up in the thermosphere, even though it has the name thermosphere, in part because of this sharp increase of temperature with height. You do see the auroras, the aurora borealis or the aurora australis. You may have had some opportunity to see the auroras at some point in your life. This is going to be an artifact of some of the energy leaving the sun, the solar wind, and as it enters the upper portion of Earth's atmosphere, we can see some pretty green, red, and blue colors, mainly in the polar regions and mainly when there's a lot of activity going on the sun. And so we talk a little bit about how do we observe Earth's atmosphere. We need to talk first and foremost about, other than our eyes, where do we get the data? Because obviously we can see and feel and sense certain things as humans, but we still measure a whole lot more, and this, as we'll see later in the semester, is critical both to understanding the current weather as well as forecasting future weather. And so we are typically going to measure data in any way that we can. We're going to measure it in ways down near Earth's surface with instruments, like one if you walk down from Colley Christopher Hall towards Urschel Hall, if you're in the business college. You'll notice on the northwest corner of the parking lot there's an instrumented weather tower. We have a weather bug station on top of this building. We have the Doppler radar on the other end of campus, but we also have satellites and things like that that can learn a lot about what's going on. We're going to try, I still have 2020 on this slide, and I actually thought about it, and I'm like, no, we're just going to leave it as 2020, because so far 2021 seems pretty difficult as well. We'll hope things change here before too long. We may try to launch a radiosonde, the idea that we can launch an instrumented weather balloon and learn a little bit about what's going on in the atmosphere above us. And it's kind of neat. They're pretty small, but we launched one last semester. I'm leaning towards doing one in this class, but when it gets a little bit warmer, where we can all congregate outside and be part of a balloon launch. And so the number of ways that we observe our atmosphere, the surface stations, the system again back behind Urschel Hall here on campus, the system that I've talked about over at the airport. Thermometers are equipped. They may be really high tech. They're not going to look like the one that you take your temperature with, but they're still going to effectively measure the temperature on a regular basis. Barometers measure pressure, anemometers, the wind, both speed and direction. Rain gauges tell us a little bit about not only how much it's rained, but the rate at which it rained. We have little buckets in there, and as each bucket fills, we can learn about how quickly they're filling and therefore how rapidly the rainfall is reaching the surface. Fancy term salometers tell us a little bit about what height the clouds are at, which can be critical towards an aircraft or an airplane trying to make an approach or landing at Porter County Municipal or Regional Airport. The radiosondes or drop wind sondes, basically, do we launch these instruments via balloon or do we drop them out of an aircraft? Which may sound kind of weird, but when we are interested in learning something about hurricanes, we actually are flying into the hurricane, at least hurricane hunters are flying into a hurricane, and they may take one of these instruments and simply kind of push it down a tube and let it come down towards the ground and tell us a little bit about the profile of the atmosphere below the aircraft. And then the radar, which we'll spend a little bit of time on, as well as the satellites. And so one thing that we need a lot of information about, and we have a lot of ways of getting it, is through what's known as the Automated Surface Observing Station Network, or the ASOS network. And so what you can see here is locations across the United States, including Alaska, Hawaii, Guam, Puerto Rico, and the Virgin Islands, where we have stations that are designed to measure it on an official basis. So for instance, you can kind of see the blue triangle indicating KVPZ through the FAA, the Federal Aviation Administration, but you aren't going to get a triangle for our station behind Urschel Hall or anything like that. So you can see where we see these stations. National Weather Service, Navy, Air Force, a number of folks have these official measurement stations that are part of the network, especially around major cities and especially in the eastern United States. Get a little sparse in areas maybe such as North Dakota and Montana, but we're still getting a lot of information through these stations. And so a simple ASOS station is going to be a relatively large tower with a number of instruments both on the tower as well as surrounding the tower. And so we can see both some stuff up here that we might be measuring the wind. We have other sensors here that are designed to measure things such as visibility and the present weather, whether or not it's raining. We have instruments like this that look like a old style mailbox that are actually looking up at the sky with a laser. That's our salometer. And so if you know any meteorology majors, you won't find them in this picture, but this is how happy a bunch of meteorology majors are. A class that I took over for one of my advanced aviation classes to the ASOS at the airport. Definitely a pre-COVID photo, and I think at this point everyone in here has long since graduated. And so we can see the data. Let me see if this pops up on the screen. Nope. Figured it wouldn't actually pull up on the wrong screen. Let's just go ahead. We can improvise, and so we can see here the data as I make this video around 8 o'clock on Thursday evening. You can see what the days look like. Again, today got up to about 26 for a high. It is cooling off rapidly with our clear skies, and so we are going to get chilly tonight. See how it is when you wake up on Friday morning. You can see if we look back, some of the light snow this morning, overnight, maybe a little bit of that lake effect stuff that came through on Wednesday evening. Information about temperature, dew point, relative humidity, wind chills. Notice how we don't necessarily have to deal a lot with a wind chill right now as I make this video because the wind speeds are calm. There's not a lot going on out there. Radiosondes, instrumented weather balloons. These are students from long, long ago that have all since graduated. And so here we have certain locations, certain National Weather Service offices throughout the country that actually put up these balloons 2 times a day, in the morning and in the evening, 6 or 7 in the morning and 6 or 7 at night. And they do this every day that exists. And it's important because this is giving us information throughout basically the entire troposphere and sometimes up into the stratosphere. We get that information back via GPS signal or some other technique. And through that, we're able to basically get information on where we might find inversions, where there's a lot of moisture in the atmosphere, where it's pretty dry. And we take this information and we ingest it into our weather models, which we'll talk about later in the semester. And so these can be quite critical if we're looking, for instance, at whether or not a severe weather event might be possible. Temperature, humidity, pressure, wind, number of different ways that we can get it back. I actually misspoke a moment ago. GPS is actually how we get the wind data. We actually get the signal back through just general radio communications. So one thing you can note is that the state of Indiana actually has no regular radiosonde launches. You can notice ones in central Illinois, out towards the Quad Cities in Iowa, Green Bay, Detroit, Wilmington, Ohio, and then all the way down in Nashville, Tennessee as you go south of us. Occasionally, we will launch a weather balloon on the request of the National Weather Service in Chicago, particularly if there's a very localized event, say a lake effect snow event. We have been known to put up a balloon to give them some information to help them out. All right, I said this one would be a little shorter, about 11 and a half minutes. Please, again, have any questions ready, and we can address those on Monday. Otherwise, if you're watching this early, have a good weekend, and if you're watching it late, hope you've had a good weekend. Take care.